Welcome students, this is part 2 of module 1 unit 3 petrology. Introduction to rocks and its types. In part 1 we have seen petrology, rock classification based on geological formation, classification within major type rocks, and we have seen igneous and sedimentary rocks. In this part 2 we will be seeing metamorphic rocks, rock cycle, civil engineering importance of petrology. Metamorphic rocks. Metamorphism literally means change. A change in pre-existing rocks under the influence of temperature, pressure and chemically active solutions. The metamorphic rocks formed from igneous rocks are called orthometamorphic rocks, and those formed from sedimentary rocks are called parametamorphic rocks. So the pre-existing rocks like igneous rocks, which is the primary rock, and the secondary rock, sedimentary rocks, are subjected to temperature, pressure and chemically active solutions. These primary rocks and secondary rocks change into metamorphic rocks. Here you have to clearly understand, from the primary rocks, that is igneous rocks, the sedimentary rocks are formed by physical or chemical weathering. The parent rock igneous and the newly formed rock sedimentary rock will have same chemical composition, whereas the metamorphic rocks, it is formed under the influence of temperature, pressure and chemically active solutions. These metamorphic rocks have chemical composition that is different from primary and secondary rocks. Some example of secondary rocks are given in this slide. Metamorphic rocks formation. The three major factors in formation of metamorphic rocks are given here. The first one is contact metamorphism. When the intrusion of magma that hits the surrounding rock causes metamorphism, it is called temperature dominated transformation. Pressure metamorphism occurs when sediments are buried deep under the ground pressure is dominant and temperature plays a smaller role in this type of metamorphism. Burial metamorphism can result in rocks such as shale. The next one is regional metamorphism. Here both heat and pressure plays a role. This is typically found in mountain link region. Types of metamorphic rocks. The first type of metamorphic rocks are foliated. In metamorphic rocks, as a result of compression and stress on the rock, the minerals within the rock align themselves perpendicular to the direction of stress. This alignment creates the banding, which is also called foliation, in the rock. The second type is non-foliated rocks. In general, many non-foliated rocks have not undergone a great amount of stress, therefore do not show foliation. Also, the minerals that compose non-foliated rocks are equidimensional crystals or equigranular crystals. As a result, no foliation would appear because all the mineral grains looks similar. Metamorphic rocks structures. The most common structure found in metamorphic rocks are gneiss structure, schistose structure, granular structure. In gneiss structure, the minerals appear as bands of flaky minerals. In schistose structure, parallel layers of minerals will be occurring. In granular structures, as you can see in the third figure, the rock is combined of granular minerals. The first figure is an example of gneiss. Next we will be seeing rock cycle. So as we seen in the igneous rocks, when the molten magma tries to come out of the Earth's interior, it can fill either the cavities inside the Earth's surface or it will reach the surface of the Earth and it starts to crystallize. Once the crystallization starts, the rocks formed are called igneous rocks. So we have also seen igneous rocks are of two types. Plutonic, when the magma fill the cavities inside the Earth's surface, and those magmas started to cool down, it forms plutonic rocks. The next one is volcanic rocks. When the magma reaches the earth's surface and it starts to cool down, crystallization occurs and the rocks thus formed are called volcanic rocks. So these type of rocks, either volcanic or plutonic, when in plutonic that formed inside the surface, comes to the surface of the earth and it is subjected to weathering, sediments form. So when igneous rocks are either mechanically or physically weathered, chemically altered, and precipitation of solution occurs, this forms sediments. Then these sediments are transported by natural agencies like wind, river, etc., and deposited in the other place. It starts to sediments over a long period of time. Upon natural compaction, sedimentary rocks are formed. These sedimentary rocks, these are some examples of sedimentary rocks. So these sedimentary rocks, due to plate tectonic movement and due to some other theories, it goes inside the surface. The pressure and temperature increases. When the pressure and temperature increase, these sedimentary rocks undergoes metamorphism and metamorphic rocks are formed. This is the example of metamorphic rocks. So when the temperature or pressure rises, this metamorphic rock starts to melt, again forms magma. This is rock cycle. So from magma, due to cooling of magma, igneous rocks are formed. When igneous rocks are subjected to weathering, sediments are formed. These sediments, when getting transported and deposition and subjected to natural compaction, sedimentary rocks are formed. This is when these sedimentary rocks are buried, it will be subjected to increased pressure and temperature, forming metamorphic rocks. So under high temperature and pressure, these metamorphic rocks begin to melt and forms magma. So this is called rock cycle. And also, this is not the only way whether these type of rocks are formed. For example, sedimentary rocks are also subjected to weathering, and metamorphic rocks are also will be subjected to weathering, forming sediment, and again those sediment will be subjected to compaction, forming sedimentary rocks. So it is a little cycle in between the larger cycle. And also, igneous rocks, when subjected to increased pressure and temperature, will form metamorphic rocks. So metamorphic rocks will be forming either from igneous rocks or sedimentary rocks. When it is formed from igneous rocks, it is called orthometamorphic rocks, and when it is formed from sedimentary rocks, it is called parametamorphic rocks. So in conclusion, so the first figure is hydrological cycle. This is how water is cycled throughout the Earth's interior. Water from the ocean gets evaporated, will reach the atmosphere, and from there it reaches the Earth's surface in the form of rainfall. Once the water comes to the Earth's surface, it flows either as a river water or as an underground water, and will reach again ocean. So this cycle is called hydrological cycle. Hydro means water. This is hydrological cycle. The next figure we have seen rock cycle. So magma upon crystallization forms igneous rocks. Igneous rocks upon weathering forms sediments. These sediments get deposited and upon natural compaction forms sedimentary rocks. This natural compaction is also called lithification, forms sedimentary rocks. These sedimentary rocks, due to the plate movement in subduction zones, goes under the Earth's surface. Once the sedimentary rocks goes under the Earth's surface, the pressure and temperature increases. So due to this metamorphism, sedimentary rocks will be changed into metamorphic rocks. So again, when the temperature is too high, this metamorphic rocks starts to melt, forming magma. So the above one is hydrological cycle, below one is rock cycle. So the plate tectonic cycle, we have seen it in clear in the first unit. The plate tectonic cycle happens due to convection currents in the mantle zone. The rock cycle demonstrates the relationship among the three major rock groups. It is powered by the interior heat of the earth, as well as earth momentum and the energy from the sun. It involves process on the earth's surface as well as the earth's interior. It connects the hydrological cycle with the tectonical cycle. Civil engineering importance of petrology. Petrology provides a proper concept and logical basis for interpreting physical properties of rocks. The study of texture, structure, mineral composition, chemical composition, etc. gives all necessary details regarding the strength, durability, color, appearance, workability, etc. of the various rocks. These inherent characters of rocks are of chief concern for a civil engineer to judicially assess the suitability occurring at project site for required purpose. Civil engineers uses rocks in different fields, like for foundation sites, for as a building stone, in highway pavements. So for using in this type of construction works, civil engineering projects, the rocks should have inherent quality and should withstand all the load and other weathering agents. So to determine whether the rock that we civil engineer going to use will have that necessary strength, durability, color, appearance, workability, the civil engineer must have a basic knowledge of petrology. For example, when the mineral composition of rocks are known, some minerals like silica are very resistant to weathering, whereas feldspar group of minerals are not much resistance to weathering. So once you know the mineral composition of rocks, you can identify whether the type of rock is resistant to weathering or not. Thank you.